Hi guys, I'm a little bit early. We're gonna go ahead and get started. Um, I think there's a glare on my little whiteboard. Hang on. I don't think that's too dark. So I decided I'm gonna wear all my math shirts to do these little videos since I have them. And otherwise, when am I gonna wear them? I would have worn them to school, right? So I'm gonna wear them. This is a shirt I would have wore on St. Patrick's Day. So I did wear it on St. Patrick's Day. I just didn't see all of you. So you didn't get to see me wearing it. Anyway, okay, so today we are going to move on to graphing the rest of the trig functions, the tangent, cotangent, cosecant, and secant. And I'm actually going to start with the cosecant and the secant because the cosecant and secant use the sine and cosine functions that we already know how to graph. So if I'm going to graph the cosecant function, which is what we're going to start with, I'm going to start by actually graphing its reciprocal. So the cosecant is the reciprocal of the sine function. So I'm actually going to start by graphing the sine function. And then we're going to look at some properties of the sine function and use those things to help us graph the cosecant function. So I'll go ahead and graph just one full period of the sine function. In order to graph one full period of the sine function, we've talked about putting your amplitude of 1, -1, going out and marking 4 equal portions on your x-axis, and that each one of those marks is either a maximum, a minimum, or an x-intercept. So since we're graphing just the normal sine function, 2 pi is our period, so that goes out here. Pi is the half period, and then pi over 2 and 3 pi over 2. That would be what our x-axis label looks like. So I'm going to graph the sine function as a dashed line using my red marker. So the sine function starts at 0, 0. Sine starts on the line is the little kind of thing that we came up with in class. So sine starts on the line would be the midline if you have it shifted up or down. Since it's sitting on the x-axis and hasn't been shifted up or down, it starts at the 0, 0. So it would go up to a maximum at pi over 2, back to the x-axis at pi, down to a minimum, and then back to the x-axis. So it's like so. So that's what the basic sine function looks like. We've graphed that lots of times. So then if I'm going to go in and graph the cosecant function, which is the reciprocal, then anytime the sine function has the value 0, the cosecant would be undefined. Makes sense? You take 0, you flip it over, then it's 1 over 0 or something over 0, in which case that's undefined. So on a graph, graphically undefined shows up as an asymptote. So every place the sine crosses the x-axis, that's where it's equal to 0, the cosecant has an asymptote. So every time the sine function has an x-intercept, the cosecant function is going to have an asymptote. So that would be the y-axis. I'm going to draw it kind of right next to the y-axis so you can still see it at pi, and then at 2 pi. And then if you think about the idea of a reciprocal, if the sine function has a value of 1 and I reciprocate 1, that's still 1, right? If the sine has a value of 1/2 and I reciprocate 1/2, now it's up here at 2, and the same would happen over here. And so what happens is we end up with, let me do a little bit better job. We end up with little kind of parabolic shapes. Think of this like the graph is increasing to 1 and then decreasing, and if you kind of flip that over like you reciprocate it, it ends up looking like little parabola shape. So the blue is the actual cosecant graph. So it includes the asymptotes here and here and here, and it also includes the little parabola shapes. The sine function, the red dotted line, is just what we use to kind of help us make the graph of the cosecant. Okay, you should be able to chat with me if you have a question. So if that's the case, please just go ahead and I will try to watch for it. Okay. All right. Um, so again, just like this is two full period, or this is one full period of the cosecant function. If I was going to graph two full periods of the cosecant function, I might graph one to the right of the y-axis and one to the left. I'm going to erase this, and we'll move on to the secant function. So if I'm graphing the secant of x, then its reciprocal would be cosine. So again, I'm going to graph the cosine and use that to make the graph of the secant. So I'm going to do the same thing. Everything else looks pretty much the same, right? So we have 2 pi out here, pi in the halfway, pi over 2, 3 pi over 2. I'm going to put 1 right there and negative 1 right there. And then cos starts at the top. Now, cos is not the appropriate way to say cosine, but if you just read it, it might look like cos. So cos starts at the top. That means we start up here at the maximum, which would be our amplitude 1. And then the next point is at the x-axis, minimum at negative 1, back to the x-axis, maximum, that's 1 full period. So it looks like that. And then the same is true. So if I have the cosine of x equals 0, those are my x-intercepts. Then the secant of x would be undefined, and those are asymptotes. So everywhere the cosine has an x-intercept, right, we have asymptotes. And then again, you kind of flip that little and create kind of parabolic shapes here. I'm going to get half of one on this side and half of one on that side for one full period. And again, the blue is the secant function. The red is just a tool. The cosine is just a tool to help us make the graph of the secant. Okay. So what if I was going to graph, let me erase this. What if I needed to graph -2 times the cosecant of 3x? We would start by graphing -2, the sine of 3x, and we would identify our amplitude, which is 2. The negative means it's going to reflect over the x-axis, so we don't want to forget about that part. And then the b value, which is 3, we calculate the period by taking 2 pi over b. So in this case, that's 2 pi over 3. And so remember, I'm going to graph 2 full periods this time. That's kind of not straight. Hang on. So remember that we put our period 2 pi over 3 out here on the last mark. So then the halfway mark would be pi over 3, and half of pi over 3 is pi over 6. And then 1/6, 2/6, 3/6, that would be pi over 2. So here's -2 pi over 3. Okay. So then we are graphing, we need to go up to 2 and down to -2. And then again, we're graphing the negative sign. So we're going to start in the downward direction. So we start on the line and then we graph down. So pi over 6 is a minimum. Pi over 3 is back to the x-axis. A maximum at pi over 2 and then back to the x-axis. And this side doesn't mirror it, continues the pattern. Sorry, like that. So it's sort of like that. So once we've graphed the -2 sine of 3x, we're going to put in our asymptotes everywhere there's an x-intercept. So there's an asymptote at -2 pi over 3, negative pi over 3, the y-axis, pi over 3, and 2 pi over 3. And then we're going to put in, Eric, it's not letting you watch. Hmm. It says it's not available. I had to use the link on Canvas. Yeah, try using the link on Canvas. I wonder why it says it's not available on my channel. Oh, okay. Well, that's good. Okay, so let's get back here. So I've put in asymptotes everywhere the red graph is the sine graph. I put in asymptotes everywhere the graph crosses the x-axis. So every x-intercept becomes an asymptote for the cosecant function. And then every one of these becomes a little parabolic shape, like so. Like that. Okay, so the blue graph, again, the asymptotes have to have the asymptotes in there, have to have the little parabolic shapes. That is what you're looking for when you make the graph of the cosecant function. So that one would be the blue, the asymptotes and little parabolas, would be -2 cosecant of 3x. Okay. So this is on the notes. I've posted the notes on Canvas, so you should be able to find those. And then you should also be able to watch this back again. It's all posted. Okay, so I'm going to erase this. So if we're going to graph for secant 1, there should be a parenthesis here, x minus pi over 2 minus 1, then we'll do the same thing. We will graph the cosine function with the 4 and everything else as well. And we'll identify our amplitude, which is 4, and our b value, which is 1/2, and then our period, which is 2 pi divided by b, is 2 pi over 1/2, which is 4 pi. Okay, see that okay over there? It's tiny. So again, I'm going to graph 2 full periods of this function as well. So same thing, 4 marks on the x-axis, 4 marks on the x-axis. We actually need an amplitude of 4, and then I'm going to keep in mind for just a second the fact that this is going to shift the graph to the right, and this is going to shift the graph down. So I'm going to need actually to go down 1 and then 4 more. So actually I need to go down to 5. So keep that in mind. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so here is my 4 pi, 2 pi, pi, and 3 pi. And then 4 would be right there and right there. Okay, 4 and -4. Okay, so then we'll start by graphing. Oh, and we also need to keep in mind that we have a shift down, which means our midline is at -1. So I'm going to draw in my midline. It's going to look weird because it's going to go right through the labels on the x-axis. It's kind of annoying, but that's our midline right there. See that? Okay. All right, so then if we're going to graph the secant function, or the cosine function, sorry, the cosine function starts at the top. So 4 marks up from the midline, 1, 2, 3, 4 would be right there. So again, remember counting up from the midline, the amplitude of 4. So up from the midline 4, back to the midline, down 4 from the midline, back to the midline, up 4 from the midline. And then we're actually going to shift the graph pi over 2 to the right. And I'm going to do that before I graph it. So pi over 2 to the right is half of this mark. So pi over 2 would be like right there, right? Each point is going to get shifted to the right a little bit. So then it looks like, sorry, I forgot to move this one. Okay, so over here it would go to the midline. So here, down 4, and then that means I'm here. Back to the midline, so I'm there. Up 4, and so I'm there. Okay, so that's everything. If I was just graphing the cosine function, I'd be done right now. So if I've graphed the amplitude of 4, I've graphed the period of 1/2, that's my 4 pi right here on there. I've shifted it to the right, that's each mark, right? I've moved each mark over pi over 2, and the midline, a -1, is my shift down. So now when I go to draw in my asymptotes, I'm drawing the asymptotes where the red graph crosses the midline, not where it crosses the x-axis. So it crosses the midline here and there, and there, and there. And so each of these have our little parabolic shapes going toward the asymptotes. Go ahead and touch. You want your graphs to touch. You want them, they have the same value at that point where the red graph has a maximum, the blue graph has a minimum. So they should touch right there. So make sure that they do. Mine is a little iffy, but just do the best you can. Okay, so that is the 4 secant 1/2 x minus pi over 2 minus 1. The blue, again, with the asymptotes and all the little parabolas. Questions? We will move on to graphing the tangent and the cotangent next. So if I'm graphing the tangent function, the tangent and the cotangent look completely different and basically have nothing in common with any of the graphs we've done so far. So that's what I was waiting for them to do last. So if I were to draw my x-axis the way I normally do, with 2 pi out here, pi over 2, 3 pi over 2, and then 1 and -1. The tangent function has asymptotes, and I'm going to actually put a negative pi over 2 over here because we need to use it. The tangent function has asymptotes at the half pi's. So I'll do it with blue so you can see it a little different. So every half pi is an asymptote for tangent. So all of these would be asymptotes. And then the basic shape of a tangent function, again, has nothing to do with anything we've done so far in the sine, cosine, secant, cosecant. They actually kind of look like cubing functions. So the graph is going to come up, pass through the origin, and then head toward that asymptote on the right side. And the same thing here. So start from the asymptote, pass through the x-axis at pi, and then head toward that second asymptote. So this is actually 2 full periods of a tangent function. One full period of the tangent function happens in pi instead of 2 pi. So if I was going to calculate, if I was going to draw the x-axis, like say there was a 4 in front of my x right there, the b value was 4. I'm going to do one in a second that looks like that. You would still put that number here on the 4th. It's just not the period of a tangent function. The period of a tangent function is half of that. It's pi. Okay, so that's what the tangent function looks like. I'm going to erase that and we'll look at the cotangent. Very similar. The cotangent looks similar to the tangent. They're reciprocals, so they have a similar shape. So they have similar shape. I'm going to go here like this. So same thing, 2 pi out here, pi in the middle, pi over 2, 3 pi over 2. If you remember, the tangent function had an asymptote at pi over 2. So just the same as if I have the cotangent, sorry, not the cotangent. If the tangent is equal to 0, then the cotangent should be undefined. So the same is true if the tangent has an undefined, then the cotangent would have a 0. So they have their asymptotes and their x-intercepts in the opposite places. So since the asymptote for the tangent function was pi over 2 and it crossed through the x-axis, the y-axis, it crossed through the origin at 0, there's an asymptote here and an x-intercept there. An asymptote at pi and an x-intercept at 3 pi. And so then that asymptote also would be at 2 pi. And then the other thing that's different between the tangent of this and the cotangent is the graph comes down to the right instead of going up to the right. So it has the asymptotes and the x-intercepts are opposite, and then it comes down to the right instead of up. So that's the basic shape. They both look very weird. Definitely different than the sine and the cosine and the secant and the cosecant, but very similar to what we did with rational functions. So when we had those asymptotes and stuff, there was often a shape like this in the middle between two asymptotes, or the cubing functions way back when. Okay, so let's do one with some transformations. I'll just do a cotangent with some transformations. The transformations I'm asking you to do with cotangent and tangent are not complicated, not like they are with the sine and the cosine. So the secant and the cosecant, I asked you to do some pretty complicated transformations. The tangent and the cotangent, I only asked you to do one of each, and they're very simple, not super complicated. So our maximum and minimum is going to be at 3 and -3. And then we don't call it an amplitude when it's tangent or cotangent. And so then the b value is 2. And if we do 2 pi divided by 2, that's just pi. So pi goes here on the fourth mark, pi over 2, pi over 4, 3 pi over 4. And then here I would put a 3 and a -3. So just like I graphed in the last one, the asymptotes are at the y-axis. You won't have any that are shifted left or right or up or down. I'm not asking you to do that. So then here are my asymptotes for cotangent. And then since it's reflected, the negative is reflecting it, right? So normally the cotangent would come down to the right. Since I'm reflecting it, it's going up to the right. And that's literally all you have to do. That's it right there. Start at the asymptote, pass through, and then head toward the other asymptote. And so that's it. So there's a worksheet on, like I said, posted on Canvas called Graphing Secants, Cosecants, Tangents, Cotangents. Take a look at it. You don't have to print it. You can just do your work on a separate sheet of paper, but you're welcome to print it if you'd like. Thanks, guys. Any last questions before I go? All right, bye.